Welcome to chapter 2, and we'll start to discuss about relation functions. Contains domain and range also. So before we go specifically into relations and function, now I want to introduce you about the graphic itself, the concept of graphing for one variable and two variables. So let's go back to the definition of solving equation. Okay, in solving equations we want to find solutions. Okay, now the next question is, what is solutions then? Okay, if we refer back to our previous chapter, solutions means all values or numbers from the specified domain which can substitute a variable or more to make the equation true or to satisfy the equation. Okay, if I want to use other definitions from internet, you can see from mathwords.com, the solution is any or and all values of the variables that satisfies an equation, inequality, system of equations, and system of inequalities. We will talk further about these later chapters. Okay, it means all values that can satisfy. You need to find all possible values, right? So now let's talk about the first example. If you want to solve this equation 4x plus 3 equals 11, what would you do? What are you doing? What is the objective? The objective is you want to find, okay, since before if we are not being specified a domain, you can assume it is from a real domain, right? So we are trying to find all possible real numbers for x that satisfy the equation. Okay, so let's see what is all possible values of x. And yes, refer to the previous chapter. That's what we are doing for x, and we subtract both member by 3. That is the first one, and the result is 4x equals 8. And then, so this is the one that being added. The second one, we multiply the result of the previous steps by 1/4. The multiplicative inverse to isolate x, right? And in the end we find that x equals 2. And because we are doing a correct algebraic steps, you can be sure that it's only one possible value, one possible real numbers that can substitute the original equation, which is 2, and you can be satisfied with that. You don't have any confusion or any curiosity. Is there any other possibility of x? Okay, x2, is there any possibility of x? No. Okay, now the next one is, if you really are uncertain about this solution, you can check, right? So previously, when we know that the x equals 2 is one of the solution, is the only one solution, you can use the form of solution set. Don't forget that we use braces. Okay, this is the form of the solution. Solution equals in braces 2. So let's just check, is 2 is the only solution. So let's just substitute 2 into the x, right? That's what we are doing. So in the end, when I'm checking, it's 4 times 2 plus 3. Is it equal to 11? Yes, it is. It is checked. So now the next one, I have already introduced you also about the number line. So instead of showing it in solution set, you can use number line to show the solution. So if you want to solve this particular equation and you know that the solution is only 2, it means if I show it on the number line, which the number line belongs to x, okay, keep in mind that the number line belongs to x because it is the number line that shows all possible numbers that can replace x or substitute x to satisfy the equation. And then to show it is 2, I just put a close circle on the 2 tick mark. And then how about if we have equations that involve more than one variable? Okay, see the difference? Before we have 4x plus 3 is equal to 11. This one. And then now let's involve y. So this is your new equation. 4x plus 3y equals 11. Now, based on the definition, let's go back to what is our objective now. Our objective is we want to find all solutions, which is all possible combinations of x and y that can satisfy the equation. So now you cannot present only one values of x or only value of y as the solution. No, the combinations between x and y. So the combination is usually written in the form of ordered pair. This is important. This is a new term, or maybe you are familiar with this, but since now I will using this term often. And what is the ordered pair looks like? It's like this. It begins with the parenthesis, and then usually if we involve x and y, so we begins with the values of x first, and then followed by the y as its combination. Okay, so let's just I show you how to find it. So the first one, when we want to solve for x plus 3y equals 11, I want to find the first combination. So this is my approach. If x equals 2, okay, then y equals 1. Okay, since this can be calculated mentally in my mind, okay, I want to find the first combination of x and y to make this true. So this is actually very mentally, and if I show you what I did in my mind, actually I try to find combinations that if 4 is multiplied by 2 and 3 is multiplied by 1, is it 11? Well, it is. Therefore, we have the first solution, we have the first combination between x and y, which is 2, 1. 2 belongs to the x, y belongs to the y. So that's how you show the first solution. It is a combination, or it is in the ordered pair form. Now let's find mentally again what is the second combination. But now I will do a different approach. So it's not by using if x equals what and then y equals what. But now if y equals 11.3, mentally I will try to calculate the following combination of x. And then I find it is 5. Since in my mind I calculate that if 5 multiplied by 4, okay, and 3 is multiplied by negative 3, it is actually 11 also, right? This is 20 minus 9. Therefore, it is 11. So I have the second solution, which is 5, negative 3. Don't forget, although I do different approach, I begins with the value of y to determine what is x. But for your solution, you need to still begin with x first and then y, since the x is 5 and the y is negative 3. So that is your second solution. But you can have the feeling here, we cannot stop here. We cannot satisfied by two possible solutions, because solving equation means you have to find all possible solutions. Therefore, I think there might be a lot there. Oh, yes, of course. But if we do it, keep doing it mentally, it will be very hard, since it's not always easy to find the combination mentally. So, to find the third pair, for example, if I can still do it mentally, right? If x equals 0, by using my mental calculation, I can find that the value of y is 11/3, which is also true, and which is it is acceptable, since all solutions must come from real numbers, the real domains. It means we can involve any non-integers, we can involve any radicals, we can involve any rational numbers. So this is what I did in my mind, since I calculated 4 times 0, which is 0, plus this is equals 11. So 0 plus 11 is 11. So it is also true. This is my third pair, 0, 11/3. So we still have many more ordered pairs then. But let's just list so far what are our solutions. So if I put it in solution set, this is how I do it. So the first solution is the combination of 2, 1. 2 belongs to the x, 1 belongs to the y. The second combinations, so I separate with comma, is another ordered pair in parentheses 5, negative 3. The third solution that I have found is another parenthesis 0, 11 third. And then you have another feeling, since solution set must provide all possible solutions, so you have to continue to find more of the ordered pairs. So instead of doing mentally, okay, there is another approach that you can find it more easily. It's easier for you to find the combination by convert. So you need to convert this equation into the statement which is y equals something. So you need to isolate y. So we are still speaking the same equation but with different form, which is y equals something. So how to convert that? Of course, you just use the algebra steps to isolate the x. So this is what I'm doing. So I begin with subtracting both members by negative 4x, or I will subtract by 4x, I'm sorry, right? So let's just go from the previous equation. So in the end, I will only have that 3y will be equals to 11 minus 4x, and then I will isolate x also by multiply it with multiplicative inverse. In the end, I will have it is this one will be your final form of your equation, the same equation, but the statement is y equals something. Okay, is it beneficial? Let's find the other pair, the other solutions. We have already had 3 solutions. Now let's find the fourth one by using this equation. So the approach is, okay, let me just put here. So now I will find another value of x, and then I will find its pair, the value of y. So if x equals 1, then when I want to find the y, I use the latest equation. I substitute 1 into the x to find the y. So you can see here, that's the steps, and I find that the pair of 1, which is the value of y, is 7 over 3. So I want to check it, is it right? So you substitute x, 1 to be your x and 7 over 3 to be your y. In the end, we have that it is 4 plus 7, it is equals 11, right? So yeah, it is true. So we have found the fourth solution. It is 1, 7 over 3 by using the latest equation. So it will become easier for you to use many variations of other value of x and then find its pair by using this equation. So yeah, we can go forth. If x equals negative 9 over 2, then y equals, you just use the same equation and then find the y, and you can go forth. Can you imagine that we are still doing endless tiring efforts to find all possible values of s of your equation? So how can you find it quicker? How can you solve it quicker? How can you show the solution sets in an easier manner, effectively all the solutions without you spending unnecessary effort? Okay, so and listing this all possible solution is not a good way for you to do that, since we have only had like 5 or 6, and then you keep doing this, you showing the list of your ordered pair one by one. It is very time consuming. It will be endless. Okay, it will be endless. So you cannot use solution set in this way. Okay, the other method that I will introduce you to show it effectively, the solutions, all possible solutions for this equation, are by graphing. Yes. Just like inequality, graphing is the most effective way to show all the solutions for your equation. So how to show you by graphing all of the solutions. So before we go to graph, let's just enlist first again what are the solutions that we have got so far. Okay, for now I'm using the table here. Okay, the first column belongs to x, the second column belongs to y, and let's just fill in the columns, the tables. So far this is for the equation 4x plus 3y equals 11. This is all the order together that we have found: 2, 1, 5, -3, and so on. So how to graph this? If we are using number line, let me just draw a number line belongs to x and a number line belongs to y, and I complete the tick marks. It's hard and it's very dilemmatic for me. By using these number lines, how can I show the pairs as a solution? Let me just begin with the first pair, 2, 1. How can I show by using these number lines that 2, 1 is one of the solution? Well, I can imagine this way. So I put a close circle here, 2, because 2 belongs to the x, and then I put another close circle 1 to the y number line. And then how can I say it is the first combination? Maybe I can use this instead. So I just connect in the line. So this is the first pair. Okay. So how I show the second pair, 5, -2. Okay, 5 belongs to the x. So it's here. So I have to extend into 5, right? And then I put close circle there. And then -3 belongs to the y. So it is here. So and then I just put a line to show it is a pair. It is a combination. Can you imagine that using this number line, I don't know how to show it, and it will be very complicated. 11/3, it's 3.6 something. So I just use it around here, right? And then yeah, this is the third pair, and you can imagine by showing in graph, if this is my method to show with number lines, it will not solving your problems to show your solutions effectively and easier, right? Since you can imagine we'll have a spider web here, and it's very hard to see all of the pairs when you want to present it as complete as possible. So yeah, number lines is not your solutions. So we have to appreciate this man, a French mathematician. It's called René Descartes. I think I pronounce it well. So he found the Cartesian coordinates. That's how we present the graph for two variables. Okay, you can recall back, you have learned this. So showing these pairs, I will complete the Cartesian. I have to show which axis belongs to the x, which axis belongs to the y. So this is mandatory. You have to state which axis belongs to the specific variables. Now, for now, you have to be clear. You still have to put the label. Okay, and then I complete the tick mark. So let me just use one unit. So it's 1, 2, 3, 4 to the right positive, to the left negative of your x value, or for your y value to the to above it's positive, below is negative.
This one is the 0 or the origin. This one is the 0.
Okay, so how can we plot this? So first, again, since we have 2, 1 as its pairs, so I show it the first pair by finding 2 value on the x-axis here, and then 1 at the y-axis, which is positive, and then find its intersection, its cross-section, I mean, right? So this is the first, okay, let me just do it like this. So this is the first pair, a dot. Okay, so yeah, so this is the by using a dot instead of a line from the previous number lines example. it's easier for us to see it, right? And then the second pair is 5 comma negative 3. 5 is here for the x, so, and negative 3 is here. The intersection will be here. For example, again, is 0. 0, 0 for the x is here, right, the origin, but the y is 11 over 3, which is 3 point something, so it is here. I'm sorry, it's hard to put the dot here. So 1 comma, this is 1, 7 over 3 for the y. 7 over 3 is like 2 point something, 2.333, so it's here. So we have 4 dots already. 4 dots represent 4 solutions, but you have to show as complete as possible, right? So you still need to find all values of x and y in between them. So to complete this, you need to do extra work, but in the end you will find a quicker way, since it must be a linear, since it will be consistently. When you find as diligent as possible you are, it will form consistently a line. I'm sorry, there's no curve there. So when you try as diligent as possible to find all the value of x between 1, 2, so 1.1, 1.2, and then you find the y, it will be thicker and thicker, and you will be certain it is actually forming a line. Okay, yeah, please pardon me with this line. You can get the idea, it is a line. Okay, so this line actually showing the solutions, and it is enough. Why? I can really, if you do it right, I can find without calculating by referring to the graph. If my x is 8, okay, what is the value of y? It means that you can just plot it. Oh, this is the intersection with the y, so this is your y. For x equals 8, yeah, this is your y. Okay, so you need to make sure this graph is really showing all the possible solutions. How? So since you are certain this is a line, you need to put these arrowheads on the edge to show that this graph will continuously infinite to that direction and to these directions, both directions. Okay, therefore this graph is sufficient to show you all possible solutions for x plus 3y equals 11. So actually this line is formed by a condensed group of many dots of your solutions.